In central Florida, inside a marshy pond, no one considered important. Something incredible happened in 1984. Construction workers stumbled upon human remains, not fragments or dust. These bodies were thousands of years old, yet they were intact. Forensic specialists struggled to understand. 168 individuals, 8,000 years old. Their brains were still inside the skulls, and locked within those brains was something science in that decade could barely touch: DNA, genetic material. It came from the oldest confirmed human settlement ever found in North America. When researchers finally sequenced this DNA, it did not just add a small note to the story of prehistoric America. It forced the entire story to be rewritten. It changed everything about who these people were. It changed how long they had lived there. It changed what kind of complex society they had already built. All of this before anyone thought such things were even possible. That is what the bog revealed. Steve Vanderjack was not looking for history. He was just operating a digger. It was 1984. He was clearing ground for a housing development in Brevard County, Florida. The pond was small, dark, and marshy. It seemed completely unremarkable. Then his machine caught something. He stopped and climbed down to look. It was round and dark brown. At first, he thought it was a rock. Rocks are rare in that part of Florida, so he picked it up. He turned it over. A human skull stared back at him. His first thought was the same as anyone's. Someone had been murdered, the body dumped in the water. Police came. A coroner examined the skull. He noticed something that immediately complicated the murder theory. The bone was dark all the way through. It was stained by long immersion in peat. This was not a recent death. It was not a police matter. The coroner made a call. That call changed everything for the site. An archaeologist was needed. Glenn Doran was a young assistant professor at Florida State University. He specialized in human skeletal remains. The call came, and he drove out, not expecting much. When he got there, the scene did nothing to change his mind. It was a small, dark pond. It looked uninviting. Unremarkable Florida scrubland surrounded it. He walked around the edge anyway. Within minutes, he saw something. Clusters of human bones were eroding out of the peat banks. Then he found 4 more skulls. Their teeth told him something right away. The wear patterns were extreme. This was not just from eating. These teeth had been used as tools. Ancient people used their teeth to grip, to work materials, to do things hands and tools do now. Modern people do not show wear like that. He knew, even before any lab results came back, that these were remains from deep prehistory. Radiocarbon dating proved him right. The bones were between 7,000 and 8,000 years old. That was 5,000 years before the birth of Christ. It was 3,000 years before the first Egyptian pyramid, 2,000 years before Stonehenge. The team felt like they were walking on clouds. They had expected old bones. They had not expected something this ancient. But there was a massive problem. The site was underwater. The bog held millions of gallons. Anything they dug up without controlled conditions would be lost. It would dissolve within hours of hitting the open air. Engineering a solution took 2 years. They sank 150 well points into the peat. Pumps ran around the clock. They pulled 2,650 liters of water out of the marsh every minute. Slowly, the floor of the bog began to appear. The engineering challenge was immense, but what larger truth awaited beneath the water only hinted at by the initial surface finds. The excavation began. What the team found was far more than a few scattered skulls. Body after body emerged from the peat. Men, women, and children. Most were curled in the fetal position. This was exactly how they had been placed by the people who buried them. Their arrangement was deliberate. It was consistent across the entire marsh floor. When the count finished, they had recovered 168 individuals. Tests on the burial ground itself showed it had been in continuous use for 1,300 years. This was no single event. It wasn't a sudden catastrophe or a mass death. This was a cemetery. A prehistoric community had returned their dead to this specific spot, generation after generation, for longer than the entire span of recorded European history. The first question any scientist asks when seeing remains this old is simple. How did they survive? Bone is organic material. Given enough time, moisture, bacteria, and acidic soil, it disappears completely. In most places, an 8,000-year-old skeleton leaves nothing. Florida's heat alone should have accelerated that process. Recovery should have been impossible, yet the Windover remains looked, to the forensic specialists who examined them, like people who had died in the last few years. The explanation was elegant and entirely accidental. The pond was a peat bog. Peat is decomposed vegetation. Over centuries, it compresses into a dense, oxygen-poor medium. This creates conditions hostile to the fungi and bacteria that cause decay. The bodies had been submerged quickly after death. They were sealed into an anaerobic environment before decomposition could begin. That alone would have slowed the process considerably. But Windover had a second factor. It made the site exceptional even among other bog sites. The peat chemistry was non-acidic. Most bogs are acidic enough to dissolve bone over long periods. This is why bog bodies found elsewhere often keep their soft tissue, but their skeletons fall apart. At Windover, the chemistry preserved both. If these individuals had been buried in ordinary dry earth, their bones would have been gone within a couple of years. The bog had done something no deliberate preservation effort of that era could have achieved. It held them intact for 80 centuries. The bodies were preserved. But what about the most delicate organ of all, and what could it reveal about these ancient people? The bodies were there, but the scientists found something else, something even more impossible than perfectly preserved bone in a Florida bog. Weeks into the dig, some of the skulls felt too heavy, much heavier than just bone should be. The team assumed peat had seeped in over thousands of years, filling the empty space where the brain once sat. It was the logical explanation. It was wrong. One skull, from a woman about 45 years old when she died, went to the University of Florida. There, an MRI scan confirmed it. The mass inside was not peat. It had structure, a defined biological structure. When researchers carefully took it out, the laboratory fell silent. They were looking at a human brain, 8,000 years old. It had shrunk to about a quarter of its original size from drying out and the pressure of being buried in waterlogged sediment. But it was unmistakable. The folds of the brain were still there. The overall shape was intact. This was a human brain, preserved so well that its cellular architecture could be seen under a microscope. Ultimately, 91 prehistoric brains came out of the Windover site. 91. That number needs a moment to sink in. These were not faint traces or impressions. These were the actual organs, the very places where thoughts had formed 8,000 years ago. The importance of this goes beyond just being a sentimental find. Our human brains have not changed in about 150,000 years. The brain sitting in that Florida lab was not primitive. It was built exactly like the brain of the scientist examining it. The Windover people were fully modern humans in every biological way. Whatever they experienced, whatever they understood, whatever they felt about their world, they processed it with the same mental structure we use today. The bog did not just preserve their bodies, it preserved the proof of their minds. This discovery changed the core question. It was not just about what had survived. It was about what secrets might still be readable inside what had survived. This find raised the stakes considerably. Could the most fragile and informative biological material of all still exist within these ancient brains, their DNA? Geneticist Bill Hausworth believed that if the cellular structure of the brains held up, then DNA might still be inside. It would be damaged and fragmented, almost certainly. But it could still be there. It might be possible to get it out. This attempt was unheard of in the history of science. It was like reaching into complete darkness and hoping to find something that had no business being there. DNA should not survive 7,000 years in a waterlogged environment. Heat, moisture, microbes, and simple chemical decay all work to destroy genetic material. The Sahara Desert had resisted ancient DNA recovery for decades for these exact reasons. Florida was not the Sahara, but it was also not the frozen permafrost of Siberia. Nobody truly expected it to work. The process involved mixing small pieces of the ancient brain tissue with enzymes. These enzymes were designed to break down cellular material. They would free any genetic content still locked inside. Then the samples went through cycles of cooling and agitation. This helped isolate what remained. Against all odds, the results came back positive: human DNA. It was not contamination from plants around the site. It was not environmental material carried in by the peat. These were human genetic sequences. They came from brain tissue that had sat at the bottom of a Florida bog for 3,000 years before the Egyptian pyramids were even built. Hausworth immediately focused on the contamination problem. This is where the entire result could fall apart. Modern human DNA from researchers handling specimens often infiltrates samples. This creates false positives. The sequences look human because they are human, just not from the person being studied. To rule this out, Hausworth compared the Windover sequences against known genetic profiles of different ethnic groups. The result was clear. The DNA was distinctly Native American. It had specific markers that set it apart from European, African, and Asian profiles. No Native Americans had been involved in handling or processing the specimens. This ruled out modern contamination with confidence. What Hausworth had recovered was genuine, Stone Age DNA from 8,000 years ago. This was the oldest confirmed human genetic material extracted anywhere on Earth at that time. The sequences gave more information than just confirming identity. They told researchers what these people looked like: dark hair, dark eyes, dark skin, a physical profile that matches modern Native American populations. These were not a mysterious lost race with no connection to the people who came later. The Windover people were direct ancestors. The genetic signature in those 8,000-year-old brains is the same one found in indigenous populations of the Americas today. They were not the start of a story that would become something else. They were the foundation of a line that has never broken. The DNA confirmed their identity, but what did their bones and cultural artifacts reveal about their daily lives and societal structure? The DNA told them who these people were, but what did they look like? To answer that, one individual was chosen for facial reconstruction. She was a woman, estimated to be about 70 years old at the time of her death. This made her one of the oldest people found at the site. Her skull was scanned, then turned into a three-dimensional model. Scientists used data on tissue depth along with her DNA profile to guide the facial features. Glenn Doran had spent 20 years studying her remains. He had never seen her face. Now, he watched the reconstruction take shape on a screen. Dark skin, dark eyes, the classic bone structure of a Native American elder. 8,000 years collapsed into a single image. She looked back into a world that had forgotten she existed. The bones did not show people just barely surviving. That is the common idea of Stone Age hunter-gatherers. A hard life, bodies worn down, always struggling to find enough food. But the Windover skeletal record told a different story. Some of the men stood nearly 1.8 meters tall. Bone density across the population showed robust physical health. These were not people eking out a meager existence. 8,000 years ago, this part of Florida was rich in resources. Rivers crisscrossed the land, game was plentiful, and the coastline provided protein year-round. The land fed them well, their bones showed it. The bones told a story of health, but not of home. To understand where these people lived, scientists looked at a technique called radioisotopic analysis. Noreen Corcoran at the Smithsonian Institution measured stable isotopes of hydrogen found in the bones. This creates a chemical fingerprint. It reflects the water a person drank during their life. Water chemistry changes by region. Drink from one source long enough, and its signature becomes a permanent part of your skeleton. The Windover team had also found animal bones in the bog from the same time. When they compared the hydrogen isotopes from the human bones to those from the animals, they did not match. The animals showed the signature of the local water source. The humans did not. This meant these people were not living right beside the bog. They traveled across the Florida peninsula, moving with the seasons. They drank from different water sources over a wide area. Windover was not their home. It was their cemetery. They kept coming back to it, often traveling long distances just to bury their dead in this one specific place. The grave goods they left confirmed the meaning of that journey. Jewelry, ornaments, weapons, all carefully placed with the bodies. They were not scattered or accidental. They were positioned with clear intention. The message was clear. These people believed in an afterlife. They were preparing their dead for it. The pond itself may have held special meaning. It could have been a boundary between the living world and whatever lay beyond it. A portal. That made this particular water sacred enough to cross an entire landscape to reach. Then came the textiles. Skeletons were found wrapped in woven fabric. This discovery stopped the excavation. Conventional understanding held that textile production this far back in time was not possible. Stone Age people wore animal hides. Weaving was a later development. It was a product of settled agricultural societies, not nomadic hunter-gatherers moving across a subtropical peninsula. America's foremost authority on ancient fabric examined the material in person. It was textile, a twined weave. This was the oldest fabric ever recovered in the Americas. The wear patterns on the fabric added another layer. Adult burials showed cloth that had been worn before death. These were garments used in life and carried into the grave. Infant burials showed fabric with almost no wear at all. This cloth was made specifically for the burial ceremony. The distinction was deliberate. Someone had woven new cloth for a child's death. That is not primitive behavior. That is grief expressed through skilled handcraft. The clearest evidence of social complexity came from a single skeleton. This was a teenager with spina bifida. The spinal condition had left his legs paralyzed. He could not hunt. He could not contribute to the food supply. Every time the community moved camp, which a nomadic group in seasonal migration does constantly, he had to be carried. The physical burden of that across difficult terrain was real and unambiguous. The tribe carried him anyway. He lived into his teens. He was cared for throughout. When he died, he received the same deliberate ceremonial burial as every other member of the community. The bog does not record savagery here. It records something considerably more demanding than that. The DNA held one more secret. Bill Hausworth did not just look at a single person. He studied genetic material from brains across the entire 1,300-year span of the burial site. When he compared these sequences, he found something unexpected. They were nearly identical. This was not the genetic diversity you would expect from an open community. Generation after generation, century after century, the same genetic signatures appeared in the same place. These were not strangers. They were family. An extended clan, all related, returning their dead to the same water for over 1,000 years. This tradition was so central to their identity that it lasted longer than most civilizations. The tribe did not mix with outsiders. The genetic record showed no outside influence for that entire period. Human contact between groups was rare back then. The Windover people remained a closed dynasty. The bog was more than a cemetery. It was the physical heart of their lineage. It was where the connection between the living and the dead stayed strong. Every burial renewed that thread. Generations never broke the practice. This kind of continuity does not happen by chance. It was a deliberate choice, repeatedly made by people who knew exactly what they were preserving. Then came Grave 102. A man, likely in his late 20s or early 30s, he was in the prime of his life. Next to his remains was a spear point. It was carved from deer antler. The first thought was a grave offering, a weapon placed with a hunter for whatever came next. The genetic continuity speaks of peace and tradition, but the spear point in Grave 102 hints at a different, darker side of their ancient lives. The excavation continued. The spear point was not lying next to the body. It was buried deep inside the man's pelvis. The tip had struck bone with such force that it stayed locked there for 8,000 years. Forensic pathologist Mike Warren used the same methods he applies to modern crime scenes. He looked at the wound's angle. It pointed upward from below. This immediately ruled out a spear thrown from a distance. A thrown spear arcs downward into a body. This wound went the other way. The man was already on the ground. Someone drove the weapon into him after he fell. The wound showed no sign of healing. It happened right around the time of death, but it was not the killing blow. No vital organs were hit. Something else had killed him first, most likely another spear strike through soft tissue, leaving no trace on the skeleton. He went down from that first attack. The second blow came after. Then came the detail that changed everything. His skull was gone. It was not just moved or lost in the mud. Every other skeleton in the bog was complete. His was not. The top 3 neck bones, the ones connecting the skull to the spine, were also missing. Warren had seen this exact pattern before, in modern cases. The man had been decapitated. The cuts on the remaining neck bones showed it was not a clean job. It involved a sharp stone tool, repeated cuts, and then brute force to remove the head entirely. Someone with the skill of an experienced hunter, someone who knew how to butcher an animal, had done this to a human being. Warren's conclusion was clear. This was not warfare. Florida was sparsely populated back then. This was personal. A grudge, a fight over land, a moment of pure rage carried to its brutal end. The head was taken, a trophy, a statement. This community had carried its paralyzed members across miles of landscape. They had woven burial cloth for their infants. Yet one man among them was hunted, killed, and deliberately mutilated. Both truths existed at the same time. They always do. The individual facts are astonishing, but what is the larger, unified portrait that emerges from all these disparate discoveries? The bog delivered an astonishing collection of material. It gave us 168 individuals preserved for 8,000 years, 91 intact brains, the oldest human DNA ever recovered at the time, the oldest textile found in the Americas, a continuous family burial record spanning 1,300 years. It even gave us a solved forensic homicide case, all without any modern evidence. Each of these findings would have been big on its own, but together they paint a much bigger picture. They show us a full portrait. The Windover people were not just a small footnote in history. They were not some primitive group that came before something better. They were a complete society. They lived with a level of social and technical skill that no one expected from prehistoric America. Existing models simply could not handle it. They wove complex fabric. They kept a sacred site going for over 1,000 years. They took care of their disabled as they moved from place to place. Their belief systems were detailed enough to include grave preparation, long journeys, and special ceremonies. They had conflicts personal enough to end in decapitation. Every single one of these facts points in the same direction. These were modern humans. They lived modern human lives 8,000 years before anyone thought to look for proof in a Florida bog. The DNA confirmed what the bones hinted at, and then it went further. The genetic continuity across 1,300 years of burials told researchers this was not a group just passing through the land. These people were deeply connected to this place. Not geographically, because isotope evidence showed they moved around, but spiritually and through their family lines, the bog was a fixed point. It organized their entire identity. They traveled across the peninsula. They always came back. The DNA proves that return. It is written in sequences so consistent over centuries that you can measure how faithful their tradition was in the genetic record itself. What science has not finished yet is the bigger question the Windover DNA opened. The DNA sequences found represent a population. This group had been in the Americas long enough to develop a genetic profile. It was entirely different from the Asian populations they originally came from. The journey from Siberia to Alaska, the time spent isolated on the Beringian land bridge, the move south as the ice retreated, then the long settlement into different pockets across the continent. All of that happened before Windover. These people were already ancient Americans when they started burying their dead in this pond. How far back that line goes remains a question. What other communities lived across the continent at the same time? We do not know yet. The databases are still growing. The recovery techniques keep getting better. Ancient DNA work in hot, wet places was once thought impossible. Windover proved that wrong. Now, it is a field that exists because of that Florida bog. There are almost certainly more sites like this one waiting. They might not have the same preservation. They might not have the same discoveries. But they all hold the same power. They can force us to rethink what we thought was settled history. The Windover Bog rewrote the entire story of prehistoric America. It showed us continuous, complex societies thriving 8,000 years ago. They lived lives driven by the same impulses that define us today. This all started by accident. A construction worker driving his machine saw something slightly wrong in a small, dark pond. The science took decades. It is still not finished. Glenn Doran, who spent his career there, says he will likely never see anything like it again. He is probably right. But Windover opened new questions. Who were the first Americans? How long had they been here? What had they built before history even began? Now, those questions have a method. The bog gave them a starting point. The DNA made it readable. The rest is still being written. The two women buried at Takurkori never knew they were the last chapter of a 50,000-year story. The man in grave 102 did not know his death would be rebuilt by forensic scientists 8,000 years later. The teenager with paralyzed legs did not know the people who carried him across Florida would one day be proof of ancient compassion. They were real people, specific, particular, irreplaceable people. They wove fabric, they honored their dead, and they kept returning to the same water across more generations than most nations have existed. The bog preserved them. The DNA read them. What they showed us was not some primitive world awkwardly before our own. It was the same world, running on the same minds, held together by the same impulses that still define us. We just needed 8,000 years in the right pond to see it. If you found this story as compelling as we did, consider subscribing for more journeys into the past.